Imagine standing on a distant planet and looking up at a sky illuminated not by one sun, but by a faint red star that never seems to move. Beyond the horizon, an endless night stretches across half the world. If intelligent life existed there, how would it adapt? Could technology transform that eternal darkness into a landscape filled with light? Questions like these once belonged entirely to science fiction. Today, they inspire real scientific research. At the center of this exploration is the James Webb Space Telescope, the most powerful space observatory ever built. Unlike traditional telescopes that focus mainly on visible light, Webb observes the universe in infrared wavelengths, allowing it to study distant galaxies, hidden star-forming regions, and the atmospheres of planets orbiting other stars. Among those planets, one attracts more attention than almost any other. Proxima Centauri b. Located just over 4 light-years from Earth, it circles the closest star to our solar system. Although incredibly distant by everyday standards, it is practically our next-door neighbor on the scale of the galaxy. Its location alone makes it one of astronomy's most valuable targets. Scientists believe Proxima b is a rocky planet roughly similar in size to Earth. It orbits within the region around its star where temperatures might allow liquid water under the right conditions. But whether such conditions actually exist remains one of astronomy's biggest mysteries. The challenge begins with its parent star. Proxima Centauri is a red dwarf, smaller and cooler than our Sun but far more active. Powerful stellar flares erupt frequently, releasing intense bursts of radiation into surrounding space. Could a nearby planet survive such an environment? Researchers are still searching for the answer. One possibility is that Proxima b possesses a thick atmosphere or a powerful magnetic field capable of shielding its surface. If those protective layers exist, they could help preserve conditions favorable for liquid water. If they do not, the planet may be exposed to relentless radiation that makes life as we know it extremely difficult. To investigate these questions, astronomers analyze tiny changes in light. As a planet passes in front of its star, a small fraction of starlight travels through the planet's atmosphere before reaching our telescopes. Different gases absorb specific wavelengths, leaving subtle fingerprints within the light. By studying those fingerprints, scientists search for molecules such as water vapor, carbon dioxide, methane, and oxygen. These observations do not reveal cities or civilizations. Instead, they help researchers determine whether a planet possesses the ingredients needed for potentially habitable environments. Another exciting field of research focuses on something called technosignatures. Rather than searching for biology alone, technosignature studies investigate whether advanced technology might produce detectable signals across interstellar distances. Possible examples include powerful laser communications, unusual atmospheric pollution, artificial satellites, or highly organized energy emissions. So far, none have been confirmed beyond Earth. But the search continues. Imagine a future discovery. Suppose astronomers repeatedly observed an unusual infrared pattern coming from a nearby exoplanet. The signal remained consistent over months of observations and appeared unlike known natural processes. Scientists would not immediately claim it represented intelligent life. Instead, they would carefully test every possible natural explanation: stellar activity, atmospheric chemistry, instrumental effects, volcanic heating, and countless other possibilities. Only after years of independent verification would more extraordinary interpretations even be considered. That cautious approach is what makes astronomy one of the most reliable sciences. Every remarkable claim must survive extraordinary scrutiny. Whether Proxima Centauri b ultimately proves to be habitable or completely hostile, it represents humanity's first opportunity to study an Earth-sized world beyond our solar system in unprecedented detail. And every observation brings us one step closer to understanding whether life could exist somewhere beyond our own planet. The search has only just begun. If Proxima Centauri b is only the beginning, the future of exoplanet exploration could be even more remarkable. Astronomers are entering an era where discovering distant planets is no longer enough. The next challenge is understanding what these worlds are truly like. Do they have oceans? Thick atmospheres? Active weather systems? Or are they barren landscapes shaped by billions of years of stellar radiation? The James Webb Space Telescope has already transformed this search by examining the atmospheres of distant exoplanets with extraordinary precision. Every spectrum collected by Webb adds another piece to a growing puzzle, revealing how planets form, evolve, and interact with their parent stars. Future observatories will push these investigations even further. The next generation of giant ground-based telescopes, equipped with advanced adaptive optics, will study nearby rocky planets in far greater detail than ever before. Planned space missions designed specifically for imaging Earth-like worlds could one day separate a planet's faint light from the overwhelming brightness of its star. For the first time in history, scientists may eventually examine the surfaces of nearby exoplanets directly. Researchers are also expanding the search beyond traditional biosignatures. Instead of asking only whether a planet could support simple life, scientists are investigating technosignatures, observable evidence that might indicate advanced technology. Examples include unusually narrow laser emissions, artificial radio transmissions, unexpected atmospheric pollutants, or energy patterns that cannot be explained by known natural processes. At present, no confirmed technosignatures have ever been detected. That remains an important scientific fact. Now imagine a fictional scenario. Suppose future observations of a nearby exoplanet repeatedly revealed a highly organized infrared pattern that remained stable through years of independent observations. The first response would not be celebration. It would be skepticism. Astronomers would investigate every natural explanation imaginable, including unusual atmospheric circulation, volcanic activity, magnetic interactions with the host star, instrumental effects, and previously unknown physical processes. Only after exhausting every conventional possibility would scientists begin discussing whether the signal might represent technology. That cautious process is exactly what makes scientific discoveries reliable. Extraordinary conclusions require extraordinary evidence. Even if no evidence of intelligent civilizations is ever found, the search itself continues transforming astronomy. Every newly studied planet teaches researchers something about planetary climates, atmospheric chemistry, geology, and the incredible diversity of worlds scattered throughout our galaxy. Some planets are scorched by their stars. Others may be frozen beneath global oceans of ice. Some could possess thick atmospheres unlike anything in our solar system. Each discovery reshapes our understanding of how planetary systems develop. Perhaps the greatest lesson from the James Webb Space Telescope is not that it has answered every question. It has shown us how many questions still remain. How common are Earth-like planets? Can life emerge under conditions very different from those on our own world? Could intelligent civilizations exist elsewhere in the Milky Way, separated from us by vast distances yet following entirely different paths of evolution? For now, those questions remain unanswered. But each observation made by Webb brings humanity a little closer to understanding our place in the universe. The search for life beyond Earth is not a race toward a single dramatic discovery. It is a long journey built on careful observations, patient analysis, and a willingness to question what we think we know. Whether the first confirmed evidence of life comes tomorrow or decades from now, one thing is already certain. Humanity has begun exploring the galaxy in ways that previous generations could only imagine. And somewhere among the countless stars, the next great discovery may already be waiting.